like you to meet Chris, our new installer. Chris, this is Pete, our installation supervisor.
Nice to meet you, Chris.
Nice to meet you, too.
We hired him from Stone Security over in Rockville. They're having a very tough time. Still use a lot of older products and techniques.
Yeah, we've upgraded a lot of their installations. Well, welcome aboard, Chris.
Thanks.
Well, I'll let you two get to work.
Okay, thanks a lot,
Take
Ned.
care.
Oh, Chris, you see the game last night?
Yeah, I can't believe they blew it.
How can they do this? They're doing this all season. I can't believe that they're from this town. Well, anyway, we might as well get you up to speed right away. I'm going to start off with something pretty easy. It's called AlarmNet. You ever hear of it?
Sure.
Ever use it? Well, it's pretty simple. This is a radio transmitter that we connect to our customer's alarm system at his home or office. Transmits alarm signals and other information to the AlarmNet network, which routes it to our central station.
Sort of like a digital dialer, only with radio waves instead of a phone line, right?
Well, it's really in addition to the dialer and phone line. The dialer isn't much use if someone cuts the phone line or if it's knocked out by a storm or service work. Even if we know the line is out, we still can't get alarm signals, so we can't respond.
Right, but radio signals go through.
Yeah, AlarmNet keeps us in touch with our customers when they need us the most. We still install a digital dialer, but the radio is what makes the system most secure.
Gotcha.
So what do you say we get started? We need a radio with installation instructions, a battery, a transformer, a programmer, and a fast tool signal strength indicator, plus some wire I'll tell you about. What we're going to do is prepare a radio to be installed tomorrow. Now, this may sound obvious, but the first thing you have to do is make sure the battery is charged. It has to read better than 12.2 volts under a load. Now we'll plug the programmer into radio. It's a regular modular phone jack and plug. Good. The programmer gets its power from the radio, you see. So now we'll wire up the transformer. This is a length of 18.2. As you can see, I've stripped off the ends. So we wire the transformer. By the way, it's just a 16.5 volt 25 VA Ademco part number 1321 TF2. Now we connect the other ends to these two AC terminals on the side of the radio, right here. Not really marked, so you just have to remember where they are. There's no polarity to observe, so just connect either lead to either terminal. Plug in the transformer. Now that the transformer is powered, let's plug in the battery. Good. Now we're ready to program the radio. Don't worry, it's a piece of cake with this menu-driven programmer. It's a simple back and forth question and answer process, sort of like a tennis game. Here, you hold it. Here, you hold it. The first thing to do is hit enter to get programmer mode. You have to proceed in 8 seconds. Good. Now all we have to do is answer some questions. First, it's asking for the 4-digit customer ID number. This can be any number from 0001 to 9999. The account number is 0009. Good. Now hit enter. Now we'll ask if the system for this area is odd. Every area has an odd or even system. This area is even. So how will we answer this question?
No.
That's right. And now hit enter. You'll always hit enter after you answer. Now it should be asking if we want 15-minute supervision. That's for really high security like fire systems. This is going to be a residential installation, so we'll answer no. Now if I had answered yes, we'd have to let AlarmNet know about it so they could set it up that way. The next one's easy. It asks if it's an AlarmNet system, so we'll always answer yes. To do that, hit the Shift key first so that the no key now becomes yes. Then just punch it in. The next thing it asks for is a central station. Ours is 11. Okay. Now we'll ask us, for each of the 4 zones of information we can communicate, if we want to invert the zone. Inverting means setting it up so that an absence of voltage would trigger the zone of information instead of presence of voltage. But we're having voltage triggers set off the alarms, so we'll answer no to all of them.
Zone 1, 2, zone 3, and zone 4.
Okay. The next question is, do we want to invert the test zone? Now, there's a test zone input here on the radio circuit board. When we're ready to test for signal strength, we'll need to activate that test zone. It's pin number 9, all right, which is 3 from the right. You see it?
Yeah.
Okay, now normally, if I apply a voltage to this pin, the radio will go into test mode. So, if I answer yes, I want to invert the zone, what would that mean?
It would mean with no voltage, it would be in the test mode.
Exactly. So let's answer no so that it stays normal without voltage.
Now it's asking fault relay on. What does that mean?
Good question. There's a relay on the radio, and here you can see it says radio fault output. It's a Form C relay, which means it can be energized.
Or de-energized.
Right. Now we want to tie this to a zone on the control panel so that if the radio is faulted for any reason at the protected premises, like if someone takes the antenna out or there's voltage trouble, it will trigger an alarm. This is important for every installation because it's what makes the radio as fail-safe as possible. So we always answer
Yes.
okay. Now, for each of the 4 zones, it will ask if we want to put a delay on, but it's a 16-second delay. But we don't want to, so we answer no for each zone.
Zone 1, 2, 3, and zone 4.
Now, it will ask for each zone whether we want to have a restore. And that just depends on whether or not the central station wants restores. Ours doesn't. So, go ahead and answer no to all of them.
Zone 1, 2, 3, and zone 4. Restore tamper.
Yeah, there's a tamper switch built into the radio.
It looks like a little reed switch.
Exactly. When the cover is on, it lines up with a magnet under the cover.
So when the cover is removed, it will send tamper signal.
You got it. Now, our central station wants to send a tamper restore so that they know when the cover is replaced. So, how do we answer?
Yes.
This is pretty easy, right, Chris?
Sure, just answer questions. It isn't so hard.
Now it should be asking whether we want to transmit openings and closings, OC. Of course, we don't do that for residential. And even for commercial, we send openings and closings over the dialer, so we always answer 0. We also answer 0 to telco for residential jobs because most people don't want us calling them at 2 o'clock in the morning just to tell them that their phone line went out for 45 seconds.
Tamper zone?
That cover tamper inside is a soft zone. We have the 4 hard zones that we've been answering all of these questions for. The tamper zone can be 5, 6, 7, or 8. We use 5.
HS ant test.
High security antenna test. This is important. This antenna goes on top of the radio. If we pull it out, the relay we talked about will trip a zone on a dialer if we tell the radio to look for it.
So always answer yes.
Always. The next question is fault latched. If we answer yes, then the fault relay stays closed until there's a failure. Then the relay opens and causes an alarm on the zone it's tied to. And when the faulted condition is corrected, the relay will close again and we'll know the radio has been successfully serviced. That's exactly what we want. So, we always answer
Yes.
okay. So high security antenna test and fault latch always get a yes.
Got it. Now it's asking if we want dual reporting. Same as the dialer can do, right?
That's right, but we have just one central station, so go ahead and tell it no.
Review.
That's it. We're done programming.
That's a lot easier than I thought it would be.
Now it's asking us if we want to review our entry. Answer yes, and then keep hitting enter to scroll through the whole program. If we had entered any illegal characters, like entered a number for a yes-no question, then there would be a question mark there instead of a review. So review means all answers are legal. It doesn't mean they're necessarily correct. We could have answered no when it should have been yes, and it would still be accepted as a legal answer. You understand? If we ever want to skip back one field, just hit Shift and then the arrow key.
Like this?
Right. At any time, we can stop on a field to change an entry.
We're back to review.
Right. Now we know everything is correct, so just hit enter.
Lights are blinking here and over on the radio.
Well, the green light shows me that the radio is now transmitting since it's programmed. On the programmer, the numbers 1 to 4 indicate the zones. It should be reading 5 for all of them, which is normal. TE is the test input. It should also read 5, indicating that we're not in test, because we're not.
It does.
TM is tamper, and it should read 1 because we have the cover off the radio, so it thinks it's being tampered with. The plus under BA shows us that the battery is charged, which is important. Well, let this operate overnight just to make sure it's charging correctly. The plus under DC tells us that the transformer is plugged in.
And FLT5?
Fault 5. What do you think it means?
I've got no idea.
Okay, well, let's look it up. On page 12, it shows us what each number on the display means.
Fault 5, VSWR, bad. Check antenna connections and cable.
Well, why do you suppose we're getting that message?
Because the antenna's not in.
Right. Put the antenna in and see what happens.
It changed to a 0.
That means radio fault conditions are cleared. But let's leave the antenna off because we don't want to conduct a test quite yet. We don't want to leave it transmitting. Okay, unplug the programmer now, and we'll let the radio charge overnight. Then we'll come back tomorrow and install it.
Sounds good to me.
How about some lunch?
That's great. I'm starved.
Let's eat. Morning, Chris.
Good morning.
We're out here because I wanted to show you the first steps in installation, the signal strength test from the field. But what we need to do first is make sure that the AlarmNet sites can receive a strong enough signal from the installation site. Now, the salesperson is supposed to verify that at the time of the sale, but sometimes they exaggerate. Sort of like their golf scores. You want to ask them what they really got?
So do we use the radio?
No, later we will. But first, we use this mini fast tool, stands for field something or other. First, though, we can just kind of look around, see if there are any obvious problems, like aluminum siding or any other metal obstacles that might interfere with the signal. Okay, doesn't appear to be any problem. Roof looks like asphalt. So it's probably a basic installation like the salesperson said.
How does the salesperson know?
Well, they use one of these when they make the sale. Now let's see if the report is right. Okay, yeah, you want to keep this on low scale. Turn it on here. Adjust the volume here. The signal strength is displayed here, and this shows us that the battery is fully charged. Okay, now here's a reading of 7. Here's a 6. What we need is 5s or better outside and somewhere inside near the control panel. Then we're in good shape. Let's go back to the shop, and I'll show you how to check it out. Okay, Chris, now check the signal strength from right here near the control.
Okay, looks like a 6 and another 6.
Good. Now, if we had to, we could install a radio right here, but we want to get the best possible reception within reason, so we'll check out the attic. Also, if we put the radio in the attic, it would be less likely to get touched and have the antenna knocked out or something like that.
So the higher up, the better.
Yeah, it's like basketball. If you're tall and you can jump high, you can shoot over the defense and score. We want our antenna to shoot signals over all the obstacles outdoors. The receiving antennas are all up high too.
Got it. The higher, the better.
Right, and we want 5s or better on the fast tool in the low scale. So let's head over to my house and we'll see what the readings would be in an actual installation location. Okay, how are we doing up here?
All right.
Make sure you're on a beam. This is your typical attic, hot and cramped. You're good, antenna straight up. Okay, what are we getting?
Looks like 7s and 8s.
Yeah. Now, there's even a 9. Well, this looks like the place to install the radio, wouldn't you say?
Looks like it to me.
Let's go back to the shop, and I'll show you how to test the radio from the installation location to the central station. The other test is just a guide.
All right.
Okay, we've left the radio plugged in overnight to make sure the battery's fully charged. You can see the LEDs blinking to indicate normal operation. So let's send diagnostics.
You want me to plug in the programmer?
Yeah, unplug the transformer and run it in on the battery just to be sure it can run on standby if necessary. Now the cover is off the radio, which would cause it to sense a tamper. We don't want that. So we're going to put a magnet next to the reed switch so that it will think the cover is on.
Pretty slick.
Well, I always carry a couple of contact magnets just for this. So what is the programmer telling us?
Well, let's see. Looks like no AC.
Uh-huh. The transformer's unplugged.
Zones are normal.
Right.
Tamper restore is being sent.
Yeah, because it sensed the cover was off and then replaced when we put the magnet there.
And the battery's good.
You got it. Now I want you to hit Shift-T to put us in the test mode.
Why doesn't it go into test mode?
It will. First it has to transmit the tamper restore, and then it will go into test mode.
How long does this take?
It could be as long as 6 minutes, but it's usually much less. It's not a high priority message like an alarm. There it goes. See how fast the amber LED is blinking? That tells you you're in the test mode.
So test signals are being sent?
Yep. Well, now we'll call the central station to see what the signal strengths were for the antenna sites we hit. Well, let's unplug the programmer now. Draws about 120 milliamps on standby, so we'll drain the battery if we leave it connected, because the transformer is not plugged in. There is a safety kickoff after 2 minutes of non-use, but it's best to unplug it. You can see that the diagnostics are still being sent, even though the program is disconnected. So let's call the central station. Yeah. So, how's it look? A 10, that's great. 3, and a 2. Okay, terrific. Thanks. Bye. Good news. The signal strengths received were 10 at one tower, 3 at another, and 2 at another.
What's the minimum we need?
Really, with just one tower with 3 or better, but we would prefer to have at least some signal at another tower too. The system is a basic backup for the digital dialer. When we do a UL installation, we need to hit 2 towers with 3 or better.
So now we know the reception's good. What's next?
We can install the radio. Now, if we were on a location site, first we would drill through to the attic so we could run wires to the control. We need 1 wire each for burglary, fire, panic, and ground, so that's 4. We need 2 more to tie the tamper on the radio to a zone on the control. We need 1 to supervise the wiring between the radio and the control, so that's 4 plus 2
7.
plus 1. That's right. So we'll pull 8 conductor, 22 gauge, plus a separate 18 tooth for the transformer. We'll use the 1 conductor left over to tie to a zone trip so we can test the radio from up in the attic where it will be installed. That really makes it easier if you're doing the installation alone. So let's go mount the radio. Okay, Chris. Now, we can mount the radio right side up or upside down, just so long as it's reasonably level. Remember, the antenna has to point straight up or straight down. Now, for this example, we'll be using the 7625 3 dB gain antenna. So the radio will have to be mounted like this. You got that? Okay, now let's get our wires connected first. We already wired the transformers to those 2 terminals on the side. Remember them?
Right. The ones that aren't marked, right here.
Now we connect 2 wires from the radio fault output back here to a zone on the control.
That way, if the antenna gets pulled out or there's some other failure, it opens a relay which trips a zone on the control, so it sends a message to the central station.
Good memory. This 3rd terminal is the test input, and this is a flying lead down to the control that we can use to trigger diagnostics without using the programmer. Remember, all I have to do is apply 12 volts to put it into test mode.
And this is the extra conductor?
Right. Now we'll connect the zones. Zone 1 will be fire. Zone 2 will be panic.
Okay.
Zone 3 will be burglary. And Zone 4 will connect to a voltage source on the control. It will have power on all the time when it's normal. That way, if the wires between the radio and the control get sliced or a radius through them, the central station will get an alarm message for Zone 4 and know about it. This is important because people are always renovating and accidents do happen. Now, since Zone 4 will always have voltage under normal conditions, is there anything else we have to do?
Sure, we have to go back into programming, and where it asks whether we want to invert Zone 4, we have to change it from no to yes, so that it will expect the voltage when it's normal.
You catch on fast.
What are these other terminals for?
ECP and ACP are for coming enhancements where we can send zone IDs from an Ademco Vista control. Now, this last wire gets tied to ground to complete the circuit for voltage triggers, and that's it. We've completed the wiring at the radio.
Now we mount it?
Yep. Now, if we install it upside down like this, right, then the antenna might get hit by someone crawling around in the attic, okay? Most attics will have a triangular area formed by the support beams that would be pretty well protected. Now, this cross beam will be good for running our wires, so let's screw the radio into place.
4 screws?
Well, there are 4 slots, but you only need to use 2. Okay, I'll plug in the transformer. You plug in the battery.
Okay.
And put the cover on.
Oh, the cover won't go on. Oh yeah, the magnet we use to keep the tamper closed.
All right. There you go. Good. Now screw in the antenna. Just have to hand tighten it. Good.
Okay.
Good. Now here. See the amber LED is solid? That means the radio is sending power on reset messages to the central station. The green blinks whenever it transmits, and the red LED, fault, should be off. Now we'll connect the radio to the control panel. By the way, if you ever need to install the radio on a solid surface and can't run wires out the back, you can just clip out any of the thin wall knockouts along the bottom of the cover and run the wires out through them.
Gotcha.
Also, when you run your wires, keep the transformer wires away from the zone trigger conductors because you don't want the AC to induce a current over into one of the voltage trigger lines.
That'll be false alarm city.
Yeah, and that would be a headache. You should also connect the radio ground to the auxiliary ground of the control, usually the auxiliary negative or the bell negative. This will create a common reference for ground, and then you won't have any false triggers caused by varying grounds.
Can you connect the AC charging of the radio to the control panel?
Yeah, you can, but only if the control panel charges at 14.2 volts or better positive DC. Otherwise, the battery won't charge fully and you'll probably get false, not to mention reduced battery life. A lot of control panels provide relay outputs to initiate responses for burglary, fire, or whatever. So you can run auxiliary power to a relay and then output it to one of the 4 zones. If the control has a single bell output for burglary and fire, you can use it to initiate separate burglary and fire radio transmissions by using an FBI 330 module. This module will differentiate between steady and pulse. Just tie the relay outputs to 2 different zones on the radio.
And the radio zones are just for basic information like burglary, fire, and panic?
Yeah, right. You use the digital dialer to send zone information and other specifics. So, let's wire the radio to the panel. Okay, now the panel is connected to the radio. We've got our transformer plugged in. Now we just need to test the complete system to make sure that an alarm message is transmitted when an alarm occurs.
So we check the system keypad, make sure all openings are closed, and then trip an alarm?
But first we call the central station to let them know what we're doing. I'll call while you check the system. Now, normally during a test, you disconnect the siren to avoid disturbing the neighbors. Okay, Chris, now set the alarm and then trip the front door zone after the delay is up. Okay, now the smoke detector. Good. Now the panic keys. Okay. Now take the antenna out. Okay, now put it back now. Okay, I'll call the central station again to make sure that they receive the signal. Okay, everything is good. They received the burglary, fire, panic, and tamper signals. So let's go over to the terminal and I'll show you what the messages look like that the central station receives. Okay, these are the diagnostic signals we just sent. This is a power on reset message. Okay, and these are the diagnostics we sent from the attic.
What are these?
These are the signal strengths at the different receiving sites, the towers. Here's a 2, here's a 3, and this means 10. Now, here's where we tested the completed system.
So let's see. Zone 3 is the burglar alarm, Zone 1 is the fire alarm, and Zone 2 is the panic. This is the tamper restore that we put on Zone 5.
Yeah, and that's everything. And that's all there is to a basic installation.
Hey, no sweat.
Most of the installations are that simple, but tomorrow I'll go over some of the tricky things that you need sometime.
Good enough.
Okay, let's get started. Now, on average, 80 to 85% of AlarmNet installations are basic installations that can be done by doing what we've already covered.
Some installations require more?
Yeah, you see, if most of your installations are inside the AlarmNet network like ours, they're more likely to be basic. If they're on the fringes of the network, they're more likely to require more advanced antenna installations. We sometimes have customers outside the network, so I'll go over the advanced antenna techniques with you. You remember what the minimum acceptable signal strength is measured on the FAST tool?
That measures signals from the AlarmNet network antenna sites to the location of the FAST tool, right?
Right.
5 is the minimum?
Right. And the minimum acceptable signal strength at the central station is 3 when you measure from the protected premises antenna mounting location to the network antenna sites by transmitting diagnostics.
Yeah, I was wondering about that. Why the difference?
Well, the difference accounts for variances in the signal path that can occur since the measurements of the signals traveling in the opposite direction. Reflections and other factors will cause them to be different.
Gotcha. So the difference is sort of a safety factor to account for any variables?
Yep, pretty much. Now, before I start talking about using remote antennas, what's the first thing to remember about mounting antennas?
Always make sure the antenna is vertical and test the signal strength from the location before you mount it.
Bingo. So let's say we couldn't get a 5 or better on the FAST device from anywhere within these premises. The first thing we should do is see if there are metal barriers that are preventing signal transmissions and whether they can be avoided from inside the premises. It's kind of like the signal is a running back and there are all these defensive backs trying to keep him from getting through. Some of these barriers are obvious.
Let's see. Metal roofs and walls, flashing, pipes, refrigerators and other metal objects.
Some are not so obvious. Metallic blinds. They may be open during the day, allowing signal transmission, but then closed at night, preventing it. Foiled back insulation inside walls. Wire lads inside plaster walls. Window screens.
Window screens? I can see through them.
Yeah, but radio waves can't pass through these screens. Light waves are very small, so they pass through easily, but radio waves are too large to pass through. Tinted glass is another barrier. Metal oxides are used to reduce or eliminate ultraviolet rays passing through the glass. If ultraviolet rays can't get in, radio waves can't get out. And in commercial installations, you have to look out for roll-down metal doors. We even had an installation where trucks were parked around a warehouse at night and blocking the signals.
Right, the metal sides.
Yeah, so we moved the radio higher. Anyway, the point is that you can often avoid these barriers and get the necessary signal strength from inside the premises by testing different spots.
And if we still can't get a reading of 5 or better inside the premises?
Well, let's say we're getting a 3 or 4. Then we would try the radio with a gain antenna, the 7625 3dB.
Okay, so with the 3 or 4 on the FAST tool, we try the 7625 3dB.
Yep, gives you 3 dB gain to get you up to 5 or better. Now, the first thing you need is a 7720 ANT antenna adapter kit. Kit has this 90-degree elbow, a replacement center disc, and 4 screws. First thing we have to do, take the cover off the radio.
Take this off.
Yeah, antenna should come off, right?
Back here.
Yeah, 2 tabs back there. Should pop right out. Good. Now attach the elbow in any of the 4 directions.
Any direction at all?
Doesn't make any difference. The only time it's important is when it's mounted, the antenna has to be vertical.
Okay.
And secure it with those 4 screws. Good.
Okay, this center disc comes out?
Uh-huh. Just turn it 1/4 turn, counterclockwise. Good. Now, replace the cover, but don't push it all the way down yet. Okay. Now first, position the new center disc on the cover and turn it 1/4 turn clockwise. Use a pen or a small screwdriver if you need to.
Okay.
Good. Now push down the cover and snap it into place. Good. The 3 dB antenna screws in right into the elbow connector.
Like this?
Yeah, looking good. Okay. Now the radio has to be mounted vertically on a wall so that the antenna points either straight up or straight down.
Okay.
Remember, test the signal strength by transmitting diagnostics before you mount it.
That seems easy enough.
It's really pretty simple. Now, let's say you can't get a reading of 3 or better on the fast tool from anywhere inside the premises. What then?
Try outside.
Right. You should then take readings on the roof. If you get any reading at all, a 1 or better, then you should plan to install a remote antenna at that location. If you can't get any reading and you're sure that your fast tool is operating properly, then we can consult with our AlarmNet representative. If network coverage is poor in an area where we might otherwise make a number of AlarmNet installations, AlarmNet will figure out whether it makes sense to install an antenna site to extend coverage to that area.
They'll really do that?
Oh, sure they will. Okay, when you install a remote antenna, plan to mount the radio inside the premises as close as possible to where the antenna will be outside. Always increase the run between the radio and the control panel rather than the run between the radio and the antenna.
Yeah, why is that?
Well, the longer the run between the radio and the antenna, the greater the loss in signal strength. Increasing the distance between the radio and the control panel, on the other hand, isn't going to hurt the performance. For runs of 1 to 5 feet, we use the 77-26-5. For runs of 6 to 12 feet, we use the 77-26-12. For runs of 13 to 25 feet, we use the 76-26-25 LL. It's a 25-foot low-loss cable with a thick black jacket. For runs of 26 to 50 feet, we use the 76-26-50 LL. Now, to remotely install the 76-25 3dB, you're going to need a 7670 antenna bracket, which comes with a bracket, lug, and silicone tape. You mount the bracket to a solid part of the structure so that the antenna is in the location you tested from. It's best to get the antenna as high as practical, out of reach of the curies and away from obstructions. The antenna works best when it can radiate in every direction. It's best to put the effort in now to avoid service calls down the road. Okay, first, place the O-ring onto the long portion of the bulkhead connector. Good. Then put the bulkhead connector into the double D slot of the ground plane. Got it? Right. The antenna bracket slides over the long portion of the bulkhead connector.
Like that?
Great. And fasten it with a lock washer and nut that come with it. Looking real good, Chris.
Okay, now this goes all the way down, right?
Yeah, that you can tighten up pretty good. You don't want that loose. That's going to be holding and supporting the antenna. Great. Now just screw the antenna in place. And just hand tighten it, though. You know, you don't want to break the center conductor. Okay.
Right about there?
Good. Yeah. Now just attach the cable.
All right, how's
Great.
that?
Looks good. Now, let me put this down. Then what we're going to do is wrap the antenna with the silicone tape.
Okay.
Okay, as you see, I've got an antenna already mounted. In the field, you would always wrap the antenna after it's mounted. You should always do it like this. Now, wrap down on the bottom. Wrap down on the bottom coupling. There you go. And be careful when using the silicone tape, since it will immediately bond to itself. Don't trap your fingers, or you'll have to start over with new tape. Looking good, real good, Chris.
Just like this?
Yep, exactly right. Good. Okay,
How far down? All the way?
that's good. As far down as you can go, just squeeze it off so it's nice and tight. Okay, now wrap up on the top coupling. Looking good, real good, Chris. Real good.
All the way up?
Yeah, all the way up. But you know, get a little sticky there, right?
Yeah.
That's supposed to happen. That's good tape. Okay, great. Okay, then with a good electrical tape, wrap down, then back up on both couplings. The final wrap has to be upward. Otherwise, you would form a cup that would funnel water into the connection. Good.
Okay.
Good. Great. Perfect. Now the bottom one. Remember, the final wrap has to be upward. Mm-hmm.
Same way, right?
Mm-hmm. Good.
Now up.
Always upward. Finish always up. Going up. Good.
Okay.
Good. Good. Now, at the point the cable will enter the premises, form a rain drip loop in the cable and secure it to help prevent moisture from getting inside.
How big of a hole do you drill?
But you drill a 7/8" hole for the connector head to pass through, and then you have to plug the extra area around the cable. Some people have their own cable. They drill a smaller hole, run the cable through, and then put the connector on. We could do this, but you really have to follow manufacturer's instructions carefully. For instance, you can't allow any part of the braid conductor to touch the center conductor, or there won't be any signal transmission. It's far easier to use pre-fitted cables. Now, let's say you need to install the 7674. That's a 6 dB gain Yagi antenna.
A what?
Yagi. Y-A-G-I. First, you secure a 1-inch galvanized pipe to the structure, and then mount the antenna using the hardware supplied so that the element is aimed upward.
Oh. Does it matter which way it points?
Oh, and that is big time. You have to point it in the right direction since the antenna focuses virtually all of the signal energy into one direction to get the higher gain. The direction is wherever the nearest AlarmNet antenna site is. You get to know them real fast, but you can always talk to the AlarmNet rep if you need one. Think of it as a baseball game, right? And the antenna is the hitter and the signal's the ball. It won't matter if the ball is hit with all the power in the world if it goes outside the foul pole.
Gotcha.
Okay. Now what do we do first?
We always test the signal strength before we mount the antenna.
Okay. Then you wrap the connections exactly as you did before. Now don't forget to make the rain drip loop.
Hey, Pete, what are these things?
Oh, right. Okay. If you're working outside, right, you can use these to protect the connectors. You just slide right over like that.
Gotcha.
Okay? Let's say you need the 7674 13 dB.
A 13 dB gain, Yagi?
Yeah. The installation is the same as the last one, except that you would use a 1.5 to 2 inch galvanized pipe. And the accurate aiming is even more critical since the signal energy is focused into an even narrower angle to achieve higher gain. Let's see, think of it as a hockey game, right? And the antenna is a stick and the signal is a puck. You can hit an awesome slap shot, but if it isn't on net, it's a waste. No score. Has to be aimed at the narrow area to work.
And a barrier would be the goaltender.
Well, I guess so, though you're not likely to have any problem on the roof. By the way, never mount this antenna to a TV antenna mast. It will act like a sail when there's wind. The resulting torque will cause it to twist the mast. Mr. Jones will be watching a game and poof, lousy TV reception, even damage. Plus, forget about radio performance, shot. Use a strong galvanized pipe. Just remember that antenna placement and installation is the most critical element of reliable radio performance. Never cut corners. And that's all there is to antennas. So let's take a break, and then I'll go over some of the advanced programming we can do.
Okay.
Okay. You know, programming the 7720 is usually simple and routine. And what we covered initially is all you need for most installations. But the radio lets you adapt it to virtually every kind of control panel and installation requirement. So let's take a look.
So if we're converting an account with a panel we don't normally install, we might use other things.
Exactly. Earlier, we went over the selection of normal and inverted zones. A normal zone is triggered through the application of voltage. But when a zone is inverted, it behaves just the opposite. An inverted zone expects to have voltage applied. It's the loss of voltage which actually initiates the alarm. Now keep this in mind while we look at another option. Now, this jumpy here allows us to easily change the way zones 1 and 2 behave without having to get back into the programming. If we leave this jumper in the low position, called plus V, zones 1 and 2 will behave exactly the way we programmed the radio a little while ago. But if we move the jumper to the upper position, where it says ground, zones 1 and 2 will behave in the exact opposite way from how they were programmed. When we first did our programming, we set up zones 1 and 2 for normal operation, which means they would be triggered by the application of voltage, right?
Right.
Okay, well, if we were to place the jumper on ground, we can take advantage of a design feature in the 7720, which allows us to use a normally closed contact connected between either of these zones and the radio's ground terminal. As soon as the contact opens and breaks the connection to ground, the alarm will be triggered. We don't even have to use the control panel for this kind of an alarm. You follow that?
I think so. So this jumper only affects zones 1 and 2 on the radio?
Right.
But what would happen if either zone 1 or 2 had been programmed for inverted operation and the jumper was placed in the ground position?
That's a good question. If either zone 1 or 2 was programmed for inverted operation with the jumper placed in the ground position, connection would have to be made between the terminal of the inverted zone and ground to trigger an alarm.
Well, how could we use something like that? It seems a little unusual.
You're right again, but suppose the radio was used with an older alarm panel which did not have individual zone triggers that we could connect to the radio. How could we trigger the radio, say, for a burglar alarm?
We could use the panel's bell output to do the job.
Yes, but suppose that the panel's positive voltage was always applied to one leg of the bell and that the panel switched the other leg of the bell to ground potential when an alarm occurred. If this were the case, we could make a connection between this leg of the bell and either zone 1 or 2 of the radio, as long as it was programmed for inverted operation. Then, with the radio's jumper placed in the ground position, the sounding of the bell would trigger an alarm at the radio. Another feature is the radio fault output jumper, which lets you select a normally open or normally closed of a Form C relay to initiate a response if the radio antenna or transmission is tampered with in any way.
How does it know if the signals are being blocked?
Well, the radio measures the amount of energy it sends out and the amount normally reflected back. If this coefficient, called VSWR, changes, it will initiate a response from the Form C relay for radio fault output. Now, if someone were to remove the antenna or cover it with a garbage can or cut an antenna cable, the VSWR coefficient would change and the radio would detect a false transmission. This would change the state of the relay, which should be tied to the digital dialer of the control panel. Now, the output here on the radio is labeled A and B. One is normally open and one is normally closed. To find out which it is, in its current position, put a multimeter across your first two terminals down here on the right. If there's a short, the fault relay is normally closed, and otherwise it is normally open.
And if it's not what I want, I just change the jumper.
Yep. One of the important features of the 7720 is the fail-safe mode. It lets you energize the coil of that fault output relay, which will then switch those A and B jumper position. If A had normally been closed, it would then become normally open, and vice versa. That's why they're labeled A and B rather than NO and NC. With the relay coil energized, if the radio loses all power for some reason, that coil will also lose power, and it can initiate a signal immediately through the digital dialer of the control panel.
What if you didn't put it in the fail-safe mode?
Well, you should get a loss of AC signal and later a low battery signal. Then there would be a COM fail to the central station within 24 hours of the power loss, or within 6 hours if you select the high security mode. We use failsafe because it means virtually instantaneous notice to the central station. Now, the terminals marked ECP and ACP aren't currently used. Leave them in ECP mode by putting the jumper on ECP in common, or the programmer won't work. Here's a few tricks with the 7720P programmer. When you program or reprogram the radio, you would usually remove power and then hit the Enter key on the programmer to reset the unit. But you don't have to remove power from the radio in the field to reset the unit. Instead, just hit Shift-X to reboot, then Shift-Y and the Enter key to initialize the radio. Once initialized, hit Enter or pound to go into the programming mode. Another tip is to trigger diagnostics from the keypad. Okay, first exit the programming mode. And we'll have to wait a few minutes while it transmits its power on reset message.
That was some game, huh?
Tough watching them, let me tell you. Ah, okay. So typically, you would use a jumper to apply voltage from DC charging to the test pin. But you could simply hit Shift-T on the programmer to trigger diagnostics. You can then hit Shift-T again to turn off the diagnostics.
Like a toggle switch.
Right. Keep in mind that diagnostics are the lowest priority messages sent by the radio. Alarm messages have the highest priority, followed by status messages regarding transmitted to network communications and then diagnostics. If the radio is transmitting alarm messages, and you would see the amber LED lit solid, then diagnostics will have to wait. If alarm messages are not being transmitted, the amber LED will blink slowly, approximately once a second. Alarm messages will always interrupt diagnostics too. Status can also be displayed immediately by hitting Shift-S on the programmer. You will see numbers and values displayed indicating the status of the radio. The meaning of each number and value is shown on pages 11 and 12 of the installation instructions, right here. Okay? Remember, you cannot use the positive DC charging voltage of the radio for your voltage triggers, because if the transformer is removed or the power fails, the voltage drops. Always use voltage from the control panel for your voltage triggers. Now, in programming, you have the option of changing the response time for each zone from 250 milliseconds, 1/4 of a second, to 16 seconds.
When would you want to do that?
The 16-second delay would be advisable if, for instance, you're using the bell output to initiate a response, and the bell has a ringback chirp upon arming to notify the user that it's functioning. The voltage change caused by the ringback would cause a false alarm transmission. With a 16-second delay, the radio does not transmit unless it still sees the alarm condition after 16 seconds. So there would be no false alarm transmission.
So the condition has to exist for the full 16 seconds.
Right. Another situation where you would want to delay transmission would be an installation where false alarms are often triggered accidentally. If the users are taught properly, they could avoid false alarm transmissions by fixing problems before 16 seconds go by. Here's another programming option. It lets you transmit to a second central station. We have arrangements with another monitoring service to allow this, but we only do this for a few special accounts. We can send alarm transmissions to ours and supervisory signals to the other, but any combination can be done, including sending all signals to both stations for redundant reporting. You would simply answer Shift-Y when the programmer asks second CS, and then answer the questions that follow. If you answer N for no, you won't even see those questions. Now, let's grab a soda, and then I'll go over some servicing tips.
It's all right here.
Okay. Most service problems involving the 7720 radio can be solved pretty easily if you just know what you're doing. On service calls, you should always carry a spare antenna, a radio battery number 7720BT, a transformer, 16.5 volt 25 VAC or more, and a spare fuse, although a bad fuse is rare. If an antenna is bent or not perfectly matched in length to the radio, it will indicate a bad VSWR.
Just swap the antenna?
Just swap the antenna. The battery could be bad without indicating it on a test meter. One of the cells could be bad, but it might not show until the battery is under full load. Just swap the battery. If the proper transformer is not being used, such as a 12-volt unit, it won't charge properly. Just swap the transformer. And you may receive a loss of AC message too. If the fuse is bad, swap it for the spare. If the central station isn't receiving supervisory transmissions from the radio, first check to see whether any metal objects, screens, tinted glass, or other metal materials have been placed or installed so that they block the signals. It can happen easily. Then do what you need to clear it. I'm going to show you how to figure out radio faults with or without a 7720p programmer. Faults are indicated by the red LED on the radio. The LED will flash in one of 5 patterns to indicate a problem. The patterns are shown on page 3 of the installation instructions.
Yeah, I see it.
The LED will light solid, then blink rapidly. There it goes.
Yeah, I see it.
At this point, it will display the fault message in a combination of 4 slow and long blinks.
Kind of like Morse code. Seems a little tough trying to decipher these and remember what they mean.
But it's really not at all. Since there are only 5 different messages, you start to recognize each of them real fast. If you're using the 7720p programmer, hit Shift S to display the status. Faults will be displayed under FLT.
Oh, right. I saw those listed right here in the installation instructions.
That's it. For example, if there's a problem with the antenna, the VSWR will be bad. This is shown by the red LED on the radio. First there's a solid and then rapid blinking. Then we get short, long, long, short. On the programmer we will see a 5, which indicates the same thing. If there's more than one type of fault, the highest priority fault will be displayed until it gets resolved. Then the next priority fault will be shown. Take a look at the installation instructions while I get some components we'll need to go over the UL installation. Okay, now, we use the 7720 for grade A and B UL listed systems. For a grade A listing, a line fault monitor, like the Ademco 659EN, has to be used. Its output has to be connected to a zone input on the 7720 radio so that if the phone line fails, the radio will notify the central station almost instantly. During programming, each of the 4 zones must be inverted and each must be enabled for restorals. The high security antenna option has to be activated, but we always do that anyway. A grade B installation can actually be more difficult because the wiring between the radio and the control panel has to be installed in rigid conduit or flexible conduit inside walls and ceilings. The doors and windows where the transmitter is located have to be protected by UL-listed intrusion devices. Just a few more things. Remember, we must use a transformer of 16.5 volt 25 VA minimum. And the last thing you know already, always test the completed system. Something could be grounded wrong or there could be some other glitch. Always do a final test and that's it. Seems like a lot, but most systems are basic and routine, and you get used to the special procedures pretty quickly.
I have just one big problem. How am I going to remember all this?
Easy. I taped the whole thing, and you can play it back as often as you please, till you have the hang of everything. The printed installation instruction has everything in it too. Like I said, most would be simple, basic installation, but you can make just about any installation if you just know how. And if you ever need any help, you can always reach AlarmNet at 1-800-222-6525.